Hello, it's Professor Stevens. I'm going to show you how to compose two functions. This is an operation on functions that we are not able to do with regular numbers. So we've learned how to multiply multiply functions together, which we can do with regular numbers as well. Divide functions, add functions, subtract functions. So all the four usual mathematical operations can be done with functions. The same as they can be done with numbers. However, this is a different type of operation that cannot be done on regular numbers, but we can do it with functions. So let me explain what this notation represents. This is called composition of functions. So when we read this, it reads find f of h of -1. Another way of saying that is find the function that is f composed with h and an input of x equals -1. So we're going to find a new function. We're going to create a new function by composing these two functions. And then we're also going to input an x value and evaluate the y. And I will start by showing you how you can do this. It might be the way that's most intuitive to you, and the reason I can do it this way is because I know I have that constant input. So I can rewrite this as, let's call this the blue function here. I'm not going to, looks too messy like that. So this is my blue function, f of x, and my purple function, g of x. And since f is mentioned first and g is mentioned, or I keep saying g. Did I say g already? If I start saying g instead of h, it's because in the textbook we usually talk about f composed with g. They're usually called g in the formal definition, but it doesn't matter which letter you're using to represent the function. So f of h is going to be put into f of x. So I'm actually going to put this entire expression in place of x inside of f. Another way to denote this is to write it like this: f of g of x equals -1. So you would evaluate this from the inside out, and I'm saying evaluate it because we are putting in a regular constant value. Then I'm going to show you how we would compose these functions with the x still left in of both functions and see that I can still get to the same result. So this is, I'm going to show you how to answer the question first by evaluating g of -1 and then putting it into whatever result I get. I will put that into f and evaluate it. So I'm working from the inside out. So first g of -1. You see how I keep saying g? I knew I was going to start saying g because it's, like I said, I'm used to saying g. This one says h. So I meant to say f of h of -1. Alright, so first I'll evaluate h of -1. And so I'm taking the original h function and leaving space for the x value. And instead of putting x, I'm going to put -1. And the left-hand side of this expression, or this equation, is notation, and it represents y. It represents specifically when x is -1, h will have a specific y value after inputting it into the function expression. So this left-hand side, actually, I don't need to do any mathematics with it. It is purely notation. Like I said, that just represents the y value of h at an x value of -1. All right, so to simplify, I have equals negative times a negative is a positive 1. 1 minus 1 is 0. Right, so h of -1 is 0. So what that means is if I have an ordered pair with -1 as the x value, the y value will be h of -1. In other words, -1, comma, 0. So moving on from there, I'm going to take that result and input it into the blue function, the outer function, f of x. So I'm going to do f of 0 now, and that'll be my final answer once I've evaluated that. Right, so f of h of -1 is f of 0 right? And so if I just copy down my f function, -4 times x minus 1, input x equals 0, and I get -4 times 0 is 0, 0 minus 1 is -1. So it's funny, right? The y value of h becomes the x value of f, and then you get a final y value. So this new function, f of h, has a point on it with a x value of -1 and a y value of -1. This one. So that is my final answer. Okay, so that is one way to answer this question, and I can do it that way because I have an input value of -1. But we also need to know how to algebraically find the composed function and be able to use it for any values of x. So now I'm going to start over and show you that solution. All right, so f of h of x is f of...
Staycation. Really? When's the last time
I have
you
an
had something like this?
add here. F of g of x. So the blue function on the outside, the first function mentioned, and I keep coming back to that g. Can't seem to stop defaulting to that. Of g of x. Alright, so I'm going to take my original f function and I'll be inputting h of x. God, I did it again. Holy moly. So h of x is -x minus 1. and this does not mean f times negative x minus 1. That f notation represents this function. So now negative 4 times the quantity negative x minus 1 plus 1, or minus 1. So to simplify that, I will distribute the negative 4 and get positive 4x plus 4, and then bring down the negative 1. So I have 4x plus 3. Alright, so I just figured out that f of h, f composed with h of x is the function 4x plus 3. So now I'm going to evaluate f of h of x, which is the same thing as saying it this way. It's just a different notation, but it means exactly the same thing. I'm going to put in a negative 1 this time. And so I'll get negative 4 plus 3 is negative 1, which is the same answer I got before. And that's composition of functions.